Okay guys, I'm going to try to keep this video short. So for 6.1 it's probably going to come to you in 3 pieces. See, in chapter 6 we start our inference section where we're talking about confidence intervals. In the past we've been using something called a point estimate in order to estimate the mean for the population. This estimate is x bar, and it's the sample mean. So in the past we've used the sample mean to try to talk about what we think the population mean is. Well, in 6.1 we get introduced to a new way to do an estimation, and that is with an interval of values. And we do that by taking the point estimate and adding and subtracting error to it. Now, this error is predetermined and it does have a formula for it. But let's just say we want to talk about, I don't know, fish. And when we do a random sample, we get the average length of the fish to be 8 inches. And if we do some magic and we calculate the error, maybe the error is 1 inch. So in the past we've said, well, maybe the mean is about 8 inches. Now we're giving ourselves a little bit of wiggle room, and we're going to say, well, the mean is somewhere between 7 and 9 inches. And there's our first confidence interval. Ooh, us, we're so smart. You see confidence intervals a lot on the news. They'll talk about a candidate is favored, or a new bill that's being proposed is favored, with 52% opposed. You like that? I said favored and then I used the word opposed. And it'll say in real small print, plus or minus 3% error. So up to 55% and down to 49% are opposed to this bill, or some kind of nonsense like that. So you've seen confidence intervals. We've just not created any for our course. Okay, so let's look at how we would create a confidence interval. In 6.1, we're interested in creating a confidence interval for just the population mean. So that means we need the point estimate, which would be x bar, and our error. Our error is calculated using the central limit theorem. So we are going to have a value for z. We're going to call it a critical value for z. So if you notice, I have a z with a subscript of c times the standard deviation for the population and divided by the square root of n. And I'm not going to lie, if you're trying to estimate mu and you know sigma, how would you know sigma and not know mu? So this is just plain silliness, but that's okay. We'll play along. We'll play the game. Alright, so our point estimate is the sample mean, and then our error is calculated by all this garbage right here. Okay. So now let's just look. I'm going to give you a confidence interval. And in this first example, the confidence interval is from 14 inches, from 10 inches to 14 inches. So I don't know the level of confidence for this, but I do know what the sample mean and the error were. So I'm giving you the answer, and I'm asking you to come up with the first 2 parts. So what is the sample mean, and what is the error? Well, the sample mean has to be smack dab in the middle. So that would be 10 plus 14 divided by 2. So the sample mean is 12 inches. The standard error would be, what did you add and subtract to get to 10 and 14? So the difference between those is 4. Cut it in half, you get 2 inches. So 12 inches plus or minus 2 inches would give me that confidence interval from 10 to 14. Ta-da, super hard, right? So I think you can handle B and C by yourself, so I'm moving on to another topic. The confidence level is determined before you get started with your problem. How confident do you want to be in this interval that you're going to create? It's denoted by the letter C, typically a lowercase c. So for example, if our problem says that C is equal to 0.95, then we're building a 95% confidence interval, and we're 95% confident that our interval actually captures the population mean. So again, for example, if my confidence interval was $100 to $150, and I had a 95% confidence interval, then I would say I'm 95% confident that the true mean is somewhere between $100 and $150. The sample mean, which was a snapshot for us, would have been $125 because it was the midpoint of my confidence interval. Okay, one more skill to look at before I turn this video off is at the bottom of the front page that how to find the critical values. So we'll give you the confidence level. So for example, the confidence level is 0.95. That represents the middle 95%. So it's this area here between the two z's that we're looking for. So the area is 0.95. The area under the total curve is 1. So if you're looking for the blank spaces that are here, they will be worth 0.05. Why? 1 minus the 0.95. But because of symmetry, these two spaces are the same size, so we need to cut this in half. So you're going to take 1 minus your confidence level and divide it by 2, and that will give you the area in these spaces. So if the area for this lower tail here is 0.025, you learned in Chapter 5 how to use your table and look this up and find out that it corresponds to a z-score of negative 1.96. So the lower z is negative 1.96 and the upper z is positive 1.96, and now you have your critical value. Okay, see you on the flip side.